All right, welcome back to the last lesson of the week, though, of the week. It's not the last lesson in math. We still have 20 more lessons to go. We have at least one more week to go of beautiful videos, right? I mean, who doesn't love the videos? There's so much fun, right? And so this is going to be lesson 100. The last lesson of the week, and the last lesson of this week is going to be surface area of right pyramids and counts. Okay, so this is going to be the lesson for today, and so let's get into it. All right, so I know most of you are going to be looking at these beautiful drawings and are going to be confused. Whoa, is this math class or art class? It is math class still, I know. But I just seem to just keep improving in my artistic skills the more I do these types of drawings. So, yeah, I might have to, have intensive art classes when we get back to school. And so, or give you guys, not me. I don't need them. You guys need them. And so what we are going to do now is we're going to look at this pyramid. Obviously, the pyramid looks like this, but when we open it up, it looks like this. And so what do we have here? Well, we have a slant height here, right? This is the slant height. And we have the base. So to find one of these triangles, we need to find, obviously, the area of a triangle. So the area of a triangle is going to be the base times the slant height. But, yeah, the slant height. Let's just call it slant height. I'm going to write the whole thing so people don't get confused. Divided by 2. And that would be just the area of one of the triangles, but then obviously a pyramid, in this case, square pyramid or even rectangular pyramid, but I don't think there's rectangular pyramids. I think there's only square pyramids. So the square pyramid has to have 4. 1, 2, 3, 4 triangles and the rectangle, and that's how we're going to find it. So, but if they ask you to find the lateral surface area, you find the area of the triangle and multiply by 4, and you got your slant height. So that's what you should know for these particular things, for this particular shape in here. We'll talk about the cone later on. Well, it also happens to be that in your book we have a different formula altogether for the lateral surface area, and it does make perfect sense, because if this is the base of this triangle, and this is the base of this triangle, and this is the base of this triangle, and this is the base of the triangle, it actually is the perimeter of the base. So what they're trying to tell you is that the lateral surface area, LSA, that's my shorthand for lateral surface area, lateral meaning the sides, is going to be the same thing as perimeter times the slant height divided by 2. Because again, we know that the area of a triangle is going to be base times slant height divided by 2 is going to be the perimeter. So all the bases times the slant height divided by 2. And that way you don't have to multiply by 4, because we already did multiply by 4 through the perimeter. And that's how you do it, and that would be it. So in the first example, they actually give you a hexagonal pyramid. I'm not going to draw a hexagonal pyramid. It's just, you guys are not ready to see it yet. Maybe I'll show it to you later. Or maybe it's that I can't draw it, But I'm inclining to believe the first statement more than the second one. So what happens is that the slant height is going to be 10 centimeters, and the regular hexagon has sides of 5 centimeters. So a hexagon has 6 sides, and 6 times 5 is going to be 30 centimeters. So the perimeter is going to be 30 centimeters, and then the slant height is going to be 10. So we have to use the lateral surface area formula, which is going to be perimeter times slant height divided by 2. So that would mean that the LSA, the lateral surface area, is going to be the perimeter 30 times 10, which is 300 divided by 2, which is, that's right, 150 centimeters squared. And there you go. I found the lateral surface area of the... All right, guys, in the last example, we're going to do cones. So for cones, we're going to use the same principle so we use for a pyramid. And so that's going to be that the base of the cone is a circle. And then, wow, beautiful. And then obviously the rest of it, right, is the cone part. Duh. And so what we're going to say is that we need the slant height, and the quote-unquote perimeter of the base. But the perimeter of the base is what we call the circumference. So you have to remember that the circumference of a circle, it is 2 pi radius. 2 pi radius. Okay? Or diameter pi. So you could do 2 pi radius or diameter pi, and then you're going to multiply that by the slant height, so I'm just going to call it S, and that would give you the lateral surface area. However, because it's also considered a triangle, we're going to divide by 2. So a way that I actually do it is I just multiply pi times radius times the slant height, and I get the lateral surface area of the cone. I don't know if your book does that. Yes, that's exactly what they do. So that is going to be how we find out the last example. And they say there's a cone, right? And the cone has a height of 12, a slant height of 13, and so the slant height is 13, the height is 12, and the diameter is going to be 10. All right, don't forget that the diameter is 10. And so we're going to have 10 centimeters, 12 centimeters, 13 centimeters. But we don't need 12 and we don't need 10. We only need 5 because of this. And so what it's going to do is that we have to leave it in terms of pi. We can't actually leave it in terms of pi. And so we're going to use the formula, and it will be 5 times pi times 13. So 13 times 5, it's really easy to figure this one out, because 5 times 12 is, why did they get, oh, it's 65. Yes, I am right. So I am right. So it is 65. The lateral surface area is 65. So it's going to be 65 pi centimeters squared. That's lateral surface area. Okay? Now, the rest of the question is find the lateral surface area and the total surface area of the cone. Now, to find the total surface area of the cone, now we have to add the lateral surface area with the area of the base, and the area of the base is area of a circle. Area of a circle is the same thing as pi radius squared, and the area of the circle then is going to be 25 pi. So 25 pi plus 65 pi, the total surface area, I'm going to call it total surface area, it's going to be 65 pi plus 25 pi centimeters squared. And so it's going to be 90 pi centimeters squared. And that's what's going to happen right here. You can actually multiply by 3.14 if you want to. Let's just do that really quickly. 3.14 times 90. And everything is going to be 0 in the first one. 0 is a placeholder. 9 times 4 is going to be 36, and a 3 goes up. 9 times 1 is 3, plus 9 times 1 is 9, plus 3 is 12, and a 1 goes up. 3 times 9 is 27, plus 1 is 28. And then we add together 0, 6, 2, 8, 2. With 2 decimal places, it's going to be 28.6 centimeters squared for the total surface area. And that is going to be the answer. And how you find both the lateral surface area for the cone and the total surface area of the cone. Hope you enjoyed this class. Take a break, you know. In the weekend, we're not going to have any math classes, but come next week, we're going to be right here again learning some more math. All right, I'll see you later.